Okay, in this little mini session chapter, you're going to learn how to simplify radicals, and you need to know how to simplify radicals in order to finish chapter 5. So, a radical is this symbol right here. And I'm going to be talking about different types of radicals. These are the different types of radicals that you might encounter. But right now, I think we're only doing square roots today. It's called a square root. So we're going to learn how to do a square root. And there's a little imaginary 2 out there. And then there could be a cube root. There could be a fourth root and so on. But right now, we are just studying what a square root is. And I think you've seen a square root before. So how do you simplify a square root? Okay, we are going to be making prime factorization trees to do this. So you have to be pretty good at your factors. And if you can't, then use your calculator. The 9 is made up of 3 times 3. There's a little imaginary 2 out there, so you are looking for pairs of numbers. Throughout this whole assignment, you're looking for pairs. And what I make the kids do is circle the 2. Do you notice that there's a pair? And for every pair you circle, you can take 1 out of the radical, so it turns into just a 3. The square root of 9 is equal to 3. And we're going to keep doing this, and you're going to get better at it. So, okay, 20 is made up of 4 times 5 is 20. You could have also used 2 times 10 in order to come up with the factors. You keep making a tree and be nice and neat. 5 can't be factored anymore, but the 4 can be factored down to 2 and 2. And remember what we are looking for? We are looking for pairs of numbers. And you circle the pairs. Do you notice that there are 2 2's? So for every pair, you can bring it out of the square root house, I call it. The 5, notice, does not have a pair attached to it. He has to stay inside. So look at problem number 1. Notice that you have nothing left under because there's nothing lingering. Where on number 2, you had a lingering 5, so he had to stay in, but the 2 got to come out. Okay, we're going to keep doing this. I guess we only have 6 more problems to example, but this is all the worksheet is all about. So let's do another one. If you don't know factors of 75, it's like 3/4. 3 25s make 75. 3 can't be reduced, but 25 can be reduced to 5 times 5. We are looking for pairs of stuff, so I circle it, and for every pair, 1 can come out of the radical. The 3 doesn't have a pair, so he stays inside. Some kids get this mixed up. The pair gets to come out. The non-pair has to stay inside. Everybody got that? The pair comes out. Some kids on the test put 3 root 5. It's the opposite. The pair gets to come out. Remember that. Pair comes out. Remember that. Okay, let's do one more and then we'll go on to the next type. 125 is made up of 5 times 25. The 5 can't be, but the 25 is 5 and 5. I'm looking for pairs. There's a pair right there. The 5 get to come out. Notice that this one doesn't have a pair. He has to stay inside. So the answer is 5 root 5. Okay, let's keep going. Let's do another 4 more and we're done with the notes. Okay, now notice that there's a number outside of the radical. I'm not going to worry about him till later. I'm just going to factor 64, the part that's under the radical. It's 8 times 8. I can stop right there because 8 is a pair. Notice where the 3 is. The 3 is already outside. The 8 is going to come out because it was a pair. The 3's already out and the 8 is coming out. 3 times 8 is 24. There's no lingering number, so this is the answer. Okay, let's do another one. The -2 is already out. He's gonna wait to see who gets to come out with the -2. 28 is 4 times 7. The 4 is 2 and 2. I'm gonna circle pairs. The -2 is out. 1, 2 gets to join it, so it's gonna be a -4 on the outside. This guy right here doesn't have a pair, so he has to stay inside. Okay, let's do 2 more. The 5, he's already out. 90 is 9 and 10. 9 is 3 and 3. Some people think 10 is 5 and 5. 5 and 5 makes 25. 2 and 5 make 10. I'm looking for pairs over here, so I'm going to circle my pairs. 5 is already out. I'm going to take out 1, 3, and 3 times 5 is 15. But 2 doesn't have a pair, and 5 doesn't have a pair. Neither one of them have a pair, so they both have to stay inside, so you have to multiply them back together again, and 2 times 5 is 10. See how that works? The 2 and the 5 do not have a pair, so they have to stay inside. Okay, let's do one more. -6 is already outside, you guys. That's already out there. 108 is 2 and 54. The 2 breaks down. The 54 is 9 and 6. The 2 breaks down. The 9 is 3 and 3. Some people think 6 is 3 and 3 also. It's all multiplied here. It's 2 times 3. This is all multiplied. There are 2 3's, and there's also a pair of 2's over here. Do you see that there's a pair of 3's and a pair of 2's? A -6 is already outside. He's already outside. A 2 can come join him, and a 3 can also join him. So altogether, a -36 is going to be outside. Notice that this little guy doesn't have a pair. He has to stay inside. Only pairs can come out and join what's already outside already. So that's all for the worksheet for Radical 1.